Hello everyone. In this presentation, I'm going to describe a new research approach, which is called Approximate Average Common Submatrix measure. This is the outline of my presentation. After a short introduction about the topic, I will provide an overview. Then I will describe our proposed approach together with the algorithm. Then I will provide some details about the experimental results, and at the end, I will thank you. Computing the similarity between two images is still a challenging task because it is quite difficult to fill in the gap between the human visual similarity and the similarity which is automatically captured by a computer. So, some main questions arise. First of all, how to find a reliable image feature descriptor. Secondly, how to find a suitable criterion for computing the affinity between the images. It is clear that a trade-off is needed between the image descriptors and affinity criterion and their execution time on a computer. So, what is the idea? Between the two images, we can compare image patches where a controlled portion of pixels is omitted at regular intervals. In this way, the similarity procedure can be still accurate, and also it reduces the execution time. So, what is the proposed approach? It is called Approximate Average Common Submatrix, which is a new measure for computing the similarity between two images. It is based on the comparison of image patches where a portion of pixels is omitted at regular intervals. So, two images can be considered as similar if they share large patches representing image patterns. In particular, two patches are considered as identical if they match in a portion of the pixels which are extracted at regular intervals along the rows and columns of the patches. The approach is based on the main assumption that two images do not need to exactly match in the intensity of every pixel to be considered as similar. It has two main advantages. The first one is that the method is robust to noise, and also omitting a portion of pixels in the image similarity reduces the execution time. This is the algorithm. The input is a pair of two images, A and B, of size n times n, and an accumulation variable, W, equal to 0. First of all, we consider the current position ij in A. This means that we scan the image A position by position. Then, we find the largest square submatrix at ij matching inside B. This means that for each position ij, we need to find the largest square submatrix starting at ij in A and matching with another submatrix inside B. The third step is to sum its area to the cumulative area double. Then we check if I is equal to n and j is equal to n. If this condition is true, so we compute the average final area, which is calculated as W divided by n times n, which is the average area, representing the similarity measure. If this condition is no, we need to come back and consider the current next position ij in A. This figure shows how to find the largest square submatrix at a sample position 5, 3 of the first image. In particular, the figure on the top right is a demonstration sample of match between two patches belonging to images 1 and 2. Each image has 4 colors, which are also numbered from 1 to 4. An interval of delta x equal to 2 and delta epsilon equal to 1 is set respectively along the columns and rows of the patches. Accordingly, the match is only verified between the elements in the red circles. The elements are selected as in a chessboard. In this case, the two image patches perfectly match because all of the elements in the red circles correspond to one another. The second image on the bottom left shows the largest square submatrix at position 5, 3 of the first image. All of the submatrices of different sides along the main diagonal at 5, 3 are considered to match inside the second image. In this case, the submatrix of size 3 has no match inside the second image. Hence, a submatrix of size 2 is considered. Because it has a correspondence at position 3, 2 in the second image, it is the largest square submatrix at position 5, 3. The A-ACSM similarity measure has been extensively experimented on benchmark image datasets and compared with other well-known measures in terms of accuracy and execution time. Results proved that A-ACSM outperforms its competitors, achieving higher accuracy in a lower execution time. This slide concludes my presentation. Thank you very much for your attention, and technical details about A-ACSM similarity measure can be found in the following international conference paper presented at CAS 2016 conference. I'm waiting for your evaluation. If you have any question, please contact me. Thank you.